Today's February 24th, 2012. That's for Jordan. Lesson 1.4. That's for Jaden. This is the work you guys are supposed to do. So page 38, letters A to G and number 1. So if you already know what we're going to do and you want to just start working on that, go right ahead. Question A has a chart that looks like this. So what we're going to do is we're actually going to go through this together because it says in the book to use a graphing calculator, which I highly doubt many of you guys have. So the very first question they've given you is graphing the original, so is f at x is equal to x squared. Okay? So if you guys recall, we're doing function notation now. So f at x is essentially what y is going to be. I'm going to bring up a graphing calculator on the computer so you can see what this parabola would look like if we go to graph it. Okay, so we're putting in the x squared. And when I hit enter, hopefully this works. Boom, there you go. So this is the original one. What we're going to do is I'm going to continuously build other parabolas on top of it so we can see the difference. This is our basic parabola. This is what everything's going to be built off of. So you guys are going to actually have to know this one quite well. We'll get into it in depth tomorrow. But in order to draw this, it has to do with squaring numbers. Now we're zoomed in quite far, so we're going to zoom out just a little here. That's a little better, okay? So all we did was zoom out a little. Our vertex is at 0 and 0. Okay, that's very important to know. And our points, in order to figure them out, we move to the right one. Then we square the number, we move to the right. We'll talk about that tomorrow. What we're going to do now is I'm going to add some extra equations to this. So a new equation. The next one on the chart says x squared.
Excuse me, sorry for the interruption. Mr. Damiani, please.
All right, so here's the next one we're dealing with. They've given us x squared plus 2. So if you take a look, the old one is a little bit faded. Our new parabola, what has happened to it? It went up 2 units. Exactly. The entire parabola has been shifted up 2 units. So what I want you guys to do right now, since that's up there, I want you to compare these, okay? So the next one they had, I'm going to put the f at x on the outside because we don't have a lot of room, is x plus 2. I want you guys, first of all, in the first one, they want us to find out what is the value of k, okay? So in the very first one, did it have a value for k?
No.
No. What number would that be considered then? 0. Good. What would the value of k be in this one?
2.
2. Good. In the first one, what direction was our parabola opening?
Right. Up.
We'll take a look. Don't worry. We'll bring it up again. See how this opens upwards. That's what we're looking for here. Okay. So it was opening upwards. We'll take the pen out. So this is what we mean by. Oh, that didn't quite. So our first one opened upwards. Where do we say the vertex was in our first one?
0.
That's right. So the coordinate of the vertex was at 0 and 0. Now, axis of symmetry.
0, 5. Oh, 0.
Let's talk about axis of symmetry. Axis of symmetry is the line that will cut this directly in half. Okay? So the line comes straight down here and would be at x equals 0. Okay? Comes right down the y-axis in this case. So when we write an axis of symmetry, we actually write it equal to a value. It is x is equal to 0 because technically it's a line going vertical, straight up and down. And finally, is it congruent to f at x? So is it the same shape? Well, yes, it's exactly the exact same question. Okay? So let's go to the second one here. Our second one, we already figured out the k value was 2. Which way was this one opening? Yeah, still open the exact same way. What happened to the vertex?
0, 2.
That's right, it moved up 2 units. Okay? Axis of symmetry.
0.
Is it in the same spot as before? Yeah, it's going on the exact same line. It didn't move left or right. It's still on that y-axis. So our axis of symmetry is x equals 0. And is it the same shape as our original one? Yes. The shape of it did not change. Okay? So that's the idea. I want you guys to go through filling out this chart. So because you didn't have a graphing calculator, I plugged in all of the equations you needed. Y equals x squared, y equals x squared plus 2, plus 4, minus 1, minus 3. Our original one was at 0. Our next one went to 2. I want you guys to deduce what you think the other 3 would be. Okay? And you're going to fill out that chart using this information. So this is all of the parabolas written, and there's the chart that you guys need to fill out. Okay, the next chart that you guys are to fill in has to deal with h, so the variable is a little different in this parabola. What I've done here is I've kept the original one. You can see it's faded. And I've put in when x minus 2 squared. And you can see that it shifted 2 units to the right. Okay? So what I'm going to do next, I'm going to pause it. I'm going to put the rest of them up and show it to you. And you guys are going to fill out that chart. So I want you guys to recognize that I've now put up 1, 2, 3, 4, 5. They're all the check-marked ones here. I've put up all of the parabolas. The original one still had the vertex at 0. Okay? Now, I want to point out one major thing here, because we didn't do these in order. When I put in y equals x minus 2, the parabola actually shifted to the right 2 units. The h variable gives us the opposite idea. So if it is a negative number, the parabola actually moves in the positive direction. If it is a positive number, it actually moves in a negative direction, okay? So I want you guys to now fill out this same chart using these 5 parabolas. You got to figure out where the vertex is, congruent, axis of symmetry, and the value of h for each of those. All right, and finally, I've put up the third graph. It's a chart that looks like this. We're dealing with the a value. So a times x squared. So we have, when it's 1, 2, 0.5, negative 2, negative 0.5. On the graph, I want you guys to recognize that 3 of them are facing upwards, 2 of them are facing downwards. By looking at these, we could probably tell that the 2 negative ones are the ones that are facing downwards. So when a is a negative number, it goes downwards. And when we had the number 2, okay, that was actually when a was 2, it's thinner. We had a thinner parabola. When we had the original one, that's the one in the middle up top, and the 0.5 made the parabola wider. So I want you guys to fill this out looking at these parabolas here. Take a look at this chart and fill this one out also.